for tuning in for another episode of Math with Mullins. Today we're going to be looking at our quiz review for lessons 7.1 through 7.3. So this is just that all-encompassing review for that. Let's go ahead and get started. The first thing I want to do is find the value of x, and I have a 1, 2, 3, 4-sided figure. So that means to find the value of x, I can take the number of sides minus 2 times 180, or 2 times 180 to get 360 as the total interior measurement. I already have 115 plus 95 and 70, so 115 and 95 and 70 will give me 280. So then now I have left is to take 280 and subtract it from 360, and I have 80 degrees remaining. Over here I have a 1, 2, 3, 4, 5, or counting all the angles, I also have 5 angles here. So that would be a pentagon, so 5 minus 2 times 180, or 3 times 180 gives us my total degree measurement. That is going to be 540. So then I look at, what do I have now? 60, 120, 150, and 75. So if I take my 150, my 120, 75, and 60, adding all those together, I get 405. So subtracting 405 from 540, I get 135 degrees for x. For number 3, this is an exterior angles, and all exterior angles have to equal 360. So what I did here is I continued to add what I had. So I had 60, 30, 72, 46, and 55 all added together. I'm going to get 263. So I'm going to take away 263 from that 360 to find out my remainder, and I'm going to have 97 degrees. For numbers 4 through 7, it says find the measure of each interior angle and each exterior angle of the indicated regular polygon. So a decagon is 10 sides, so I'm going to be doing 10 minus 2 times 180, or 8 times 180. That's going to give me 1,440, and I'm going to divide that by 10 to find each exterior angle, or interior. So my interior would be 144 degrees. Then my exterior, I would just take my 360 and divide that by the number of sides, 10, and I'm going to get 36 degrees for exterior. Okay, 15agon, let's do it the same way. I've got 15 minus 2 times 180, or 13 times 180. That is going to give me my 2,340 total, but dividing that by 15 gives me my interior amount of 156 degrees. Exterior can be found by taking 360, dividing that by 15, and I'm going to get 24 for exterior angles. 24agon, starting the same way, 24 minus 2 times 180, or 22 times 180. I'm going to get 3,960, divide that by 24 sides. My interior measurement will be 165 degrees for each one. Exterior, just take that 360, divide it by 24, and I'm going to get 15 degrees. Okay, 60agon, last one here. 60 minus 2 times 180 is going to give me big old number, 10,440. Divide that by 60 for my interior measurements. I'm going to get 180. Let's just double check that math real quick. So I've got 58 times 180, and then divide it by 60. There we go, 174. Oops. And then for exterior, 360 divided by 60, 6 degrees for each exterior angle. Up next, I have find the indicated measure in ABCD and explain your reasoning. So with CD, I'm going to have to say that CD is equal to 16, because when you have opposite sides, they're going to be equal. For number 9, AD is here, and that's also going to be equal to BC, opposite sides. AE is a diagonal, and it's going to be equal to the other diagonal, which would be also 7 from E to C. BD is the entire length of the diagonal, and we would just use that 10.2 shown. So 10.2 and 10.2 together makes 20.4. For the measure of BCD, that's going to be the same measure as the opposite of BAD, so that's 120 degrees. That's the parallelogram opposite angles theorem. Angle ABC is going to be the same as ADC, but notice I only get one of those angles, so that's another 43. 43 and 43 makes 86, so ABC should be, for number 13, also that. Or I can look here and show if this is 120, this has to make a supplementary angle. So that would actually be better to look at. For ABC, that would be 60 degrees. Then for number 14, ADC would also have to be 60 degrees because that's again, the parallelogram consecutive angles. And then DBC, that one is going to be the 43 degree angle because that one's the alternate interior angles. Okay, so that one was kind of tricky with those last three. 16 through 18, state which theorem you can use to show the quadrilateral is a parallelogram. So for 16, I would use the opposite sides for parallelogram and congruency theorem. For number 17, I could use the parallelogram diagonals converse. For number 18, I could use the parallelogram opposite angles converse to help me. For number 19 and 20, it says graph the quadrilateral with the given vertices in a coordinate plane, then show that the quadrilateral is a parallelogram. So the first thing I would do is go ahead and label my Q, my R, 3, -2, S, 1, -6, and T is -7, -6. Okay, and then I would go ahead and graph each one of those points or connect them. And then I just want to prove, is this a parallelogram? So what I would need to do is look at maybe QR and ST to see if it's parallel, and then RS and TQ. And I'm just going to talk about the slopes. Okay, so for QR slope, I'm going to have -2 minus -2 over 3 minus -5, so that'd be 0 over 8, 3, oops, I definitely drew this one wrong. This is what I get for doing a video first thing in the morning. -5, -2 should be down here. I knew that looked a little weird. I'm like, this is not a parallelogram. I'm glad I used my points for that. So QR has a slope of 0, which means the slope for ST should also have 0. And if I look at my points, -6 minus -6 and -7 minus 1, I still get 0 over -8, which is still showing me 0 as a slope. So these are parallel. Do my parallel sign. Okay. And then QT and RS have to have the same slope. So for QT, I would do -6 minus -2 over -7 minus -5. That's going to be -4 over -2. So that's +2 as my slope. And then SR, if I just count up 1, 2, 3, 4 over 2, I also get a 4 over 2, so that's also having a slope. So yes, it's a parallelogram. Okay. For number 20, I've got -3, +7 for W, 3, 3 for X, Y is 1, -3, and Z is -5, +1. Okay, for this one, as I connect all my points, I just want to check my slopes, and I already found those for us real quick. So slope WX is -2/3, ZY is -2/3, XY is a +3, oops, and WZ is also a +3. So all these slopes are the same, so we could say yes, or the opposite slopes are the same, so we could say yes, this is a parallelogram. Oh my gosh. Okay, one more question. A stop sign is a regular polygon. This stop sign is an octagon because 8 sides. And then each interior and exterior angle, this would be 8 minus 2 times 180. So 6 times 180 gives me 1080. Dividing by 8 gives me 135 for interior. Exterior, just 360 divided by 8 gives me 45 for the exterior. Okay, that will conclude our review on 7.1 through 7.3. Sorry about the slope mishap. Thanks for being patient with me and tuning in. Hope this helps you on your quiz, and we'll catch you next time for a little bit more review of different shapes. Have a great day.